In this video, we'll be learning about the tangent. So a tangent is a line, a plane, or a segment that's in the same plane as a circle and touches a circle in exactly one point. So 1 point and 1 point alone. In this circle, the point that the tangent is touching, so this is the tangent line right here, the point that it's touching is right here. And that point is called the point of tangency. So let's write some stuff down here. That point right here is called the point of tangency. And this line here is called the tangent line. Again, it could either be a ray or a segment as well. All right, so if I have multiple circles, they can have a common tangent. So let's say we have another circle here. I could have multiple lines that go through this space here, or this space here, or right here, or right here. That's tangent, common, a common tangent to both circles. It's a little hard to draw, but I'll try to put one in so you can see it. And let's see. Oh, well, imagine if my line wasn't so bendy and it touched 1 point here and 1 point here. That would be considered a common tangent to both circles. So that's basically what a tangent is. Again, it's just a line that touches, a line, segment, array that touches a circle in exactly 1 point. All right, so there's a few theorems that I want to go over having to do with the tangent. The first theorem having to do with tangents that I'd like to go over is this. If we have a tangent, so we have a tangent here, this tangent is definitely going to be perpendicular to the radius that touches the point of tangency. So I'm going to draw that radius in. So that radius is touching the point of tangency, which means that it will definitely be perpendicular to the tangent. So the radius and the tangent at that point are always perpendicular to each other. And it doesn't matter if the line, the tangent line, is up here and the radius is here, it's always going to be true. All right, doesn't matter where that point of tangency is on the circle as long as it's on the circle. All right, let's look at an example where we would be able to use this point. Okay, so in this example, we're being asked to figure out if the line segment KL is tangent. Or is a tangent. So we know that JL is a radius, and we know that we have a triangle here. If KL is in fact a tangent, it's going to be perpendicular to JL, which would make this a right angle, which would make the entire triangle a right angle triangle. Good. So if this is a right angle triangle, what relationship holds true for the sides of a right triangle? If you said the Pythagorean theorem, you are correct. So if this is in fact a right triangle, then 8 squared plus 15 squared will give us 17 squared. And this is a question right now. We're not sure. We have to test it out. So when we do 8 squared plus 15 squared, we should get 289. And when we do 17 squared, we should also get 289, which shows that the Pythagorean theorem is true, which shows that this is in fact a right triangle. Therefore, 15 and 8 are sides of a right triangle, which means that KL is tangent to the circle. So yes, it is. The second theorem that I want to show you is this. If I have a point, so let's say I have a point right here at B, and I draw a tangent segment to the circle. So I draw a segment AB to the circle that's tangent, and I draw a second segment that's tangent to the circle. It is the case that both of my segments are going to be congruent to each other. So that's going to be the case from any external point. So it doesn't matter if it's point B or any other point. It could be over here. If I draw two tangents from there, they're going to be the same length as each other as well. All right, so we can actually do a quick example with this. And so I'm going to say, let's say this is x plus 15. And let's say this is 2x minus 5. And even if we didn't have these hash marks telling us that these are equal, we would know because of the theorem we just spoke about. So in order to figure out what x is, we would just say x plus 15 is equal to 2x minus 5. I could go ahead and subtract x from both sides to get that 15 is equal to x minus 5. I could now add 5 to both sides, and I would get that x is equal to 20. And that's how you would go about figuring out what x is in this case using that theorem. The last thing that I wanted to do in this video is define a circumscribed polygon. So if we have a circle, so I'll just draw one, it won't be perfect, but there we go. So if we have a circle and we have a tangent, or every side of the polygon is tangent to the circle, so let's make that more of a tangent. All right, we'll pretend. All right. Every side of the polygon is tangent to the circle. So if that is the case, our polygon is said to be circumscribed about a circle. So a polygon with all sides tangent to a circle is called a circumscribed polygon. All right, that's it for now.